So this is now, I mean, this is, you can kind of see how a data compression idea would work, because first of all, if you just look at this, on the right you have all these lines, right? So this is like a whole bunch of data here potentially, but on the left it's pretty much black, except you have these peaks here, right? So you can just intuitively guess which would require less memory to save, this or this. Right? So the idea is that with data compression, you just need to store the information of the individual peaks there. Yeah. Okay.
That's when you were talking about the discrete points that you.
Yep. Yeah. Yeah. So I mean, and with this example, it's quite dramatic, because I mean, you were just singing one pitch, right? And so it was fixed. If you think about a song or a conversation, it's much more complicated than that, because we're not speaking at a single pitch. We have dynamics and we have different enunciations. So all of that has to go into a data compression algorithm. And so we all have familiarity with these, with whether it's your iTunes or MP3. These are all technologies that are employing these concepts into the audio compression. And so we're going to actually look at now a more realistic type of compression, not where it's not just at a single pitch, but on an actual song.
And then the last module that we have is the audio compressor. So the idea was described that instead of sending the time domain signal where you record the audio sounds at every single moment in time, if you instead send the amplitudes of the sinusoidal signals, you can compress the audio. So this is how programs like MP3 work. So we're going to play the Marching Illini fight song, and we'll listen to it, the original version of it. So you can see all the frequencies that are contained in the signal. So audio goes all the way up to about 20 kilohertz. And so that's how the full signal is represented. We keep track of every single moment in time what the amplitude is. And so you get this really rich spectrum in the frequency domain. If we instead play the compressed version, so what it's doing is it's only keeping the top 256 signals. And you can almost get the same quality as the original with only 256 numbers rather than all of the points. Now, if I want to compress it further, so let's say I only keep the top 64, you can hear a little bit of the clicking, so it doesn't sound as high quality. And if I go down further, so if I go to 16, these are only the top 16 sounds. It definitely sounds like computer garbled, but the compression, the amount of data that we save by not having to send all the signals is significant. So I'm going to do 4, and then I'll do 1. You can kind of recognize the song if you're an Illinois student. And then when you get to 1, it's really tough. So you're only keeping one sinusoid at different moments in time, but you're allowing that to change a few times. All right, so that sounds really, really bad, but we get the most amount of compression.